To understand how a neural network classifies an email, we first need to translate text into numbers that a computer can process. Break time equals 0. Imagine we have an email and we are looking for specific keywords like free, win, and offer. Break time equals 1. Zeros, we represent this email as a feature vector, which is essentially a numerical list. Break time equals 0. In our example, the word free is present, the word win is absent, and the word offer is present. Break time equals 1. This gives us a simple input vector of 1, 0, and 1. Break time equals 0. This numerical snapshot is what the input layer of our network actually sees. Break time equals 1. Zeros, each position in this vector tells the network whether a specific indicator of spam has been detected in the raw data. Break time equals 1. Zeros, by converting text into these binary signals, we create a foundation for the mathematical operations that follow. Once the input vector enters the network, it moves to the hidden layer. Break time equals 0. Here, each neuron, like neuron H1 and neuron H2, has its own unique set of weights. Break time equals 1. Zeros, these weights represent the importance or the strength the network assigns to each keyword. Break time equals 0. To find the weighted sum for neuron H1, we multiply our input values by the weights 0.5, negative 0.2, and 0.3. Break time equals 1. Adding these results together gives us a total of 0.8. Break time equals 0. We perform a similar calculation for neuron H2 using its specific weights, which results in a value of negative 0.1. Break time equals 1. This process is how the network begins to aggregate the raw signals from our keywords into more complex internal patterns. Break time equals 1. Zeros. It is the first step in transforming simple word counts into meaningful information. After calculating the weighted sums, the network applies an activation function to introduce nonlinearity into the system. Break time equals 0. In this case, we use the rectified linear unit or ReLU function. Break time equals 1. ReLU is a straightforward but powerful tool. If a value is positive, it stays exactly the same, but if it is negative, it is changed to 0. Break time equals 1. Zeros. For neuron H1, the input of 0.8 remains 0.8 because it is positive. Break time equals 0. However, for neuron H2, the negative 0.1 is clamped to exactly 0. Break time equals 1. This step is crucial because it decides which neurons are actually firing and contributing their information to the final decision. Break time equals 1. Zeros. It allows the network to effectively ignore irrelevant or negative signals that do not help in identifying the email as spam. Finally, these activated values from the hidden layer are passed to the output layer for the final verdict. Break time equals 0. The network performs one last weighted sum using the values 0.8 and 0. Break time equals 1. Zeros. After applying the output weights of 0.7 and 0.2, we get a combined value of 0.56. Break time equals 0. To turn this into a readable probability, we pass it through a sigmoid activation function. Break time equals 1. The sigmoid function squashes the value into a range between 0 and 1, giving us a final result of approximately 0.636. Break time equals 1. Zeros. Because this value is greater than our decision threshold of 0.5, the network officially classifies the email as spam. Break time equals 1. Zeros. This mathematical journey from keywords to a final probability shows how layers of simple calculations can solve complex classification problems.